Assalamualaikum warahmatullahi wabarakatuh. Good morning. Here I will present my article entitled Effect of Ferrous Cement with GGBFS Substitution by Anis Purwaningsih, Malang, 25 November 2023. The 5th International Conference on Universal Well-Being, 20 and 23. What is ferrous cement? Ferrous cement is a thin, reinforced concrete formed from hydraulic cement mortar, which is treated with several layers of wire as the main reinforcement, with a relatively small wire diameter. Ferrous cement is known to have good strength, flexibility, and durability when compared to other conventional technologies. This is the picture of ferrous cement with mortar and wire mesh or chicken mesh reinforcement. Research background. Ferrous cement is commonly used in cell structures because in cell structures the main stresses are compressive stresses and tensile stresses are only present at the edge of the cell. Since ferrous cement uses dense reinforcement and is formed according to the desired cell curve, the mold is only needed to support the reinforcement, and the mortar concrete will be held in place by the reinforcement. Thick mortar concrete, such as for spray on siding, was used. The cement sand ratio used is 1.2 to 2 and the water cement factor is 0.3 to 0.55. This is an example of the application of ferrous cement in a cell structure. Problem and solution. To reduce cracking due to head of hydration of cement, ferrous cementers are advised to use low head of hydration cement such as PCC or Portland cement composite and slag cement mixed for mortar materials. The PCC and slag cement mix will provide low porosity, making it suitable for watertight structures. This is the example of specimen. Mortar for compressive strength, mortar for deep penetration, water deep penetration, and ferrous cement specimens. Results. This is the graphic compressive strength with GGBFS. Compressive strength increased due to GGBFS substitution with an increase of 15%, 19%, and 18% for 10%, 20%, and 30% GGBFS substitution. This is water penetration depth with GGBFS. Water penetration depth decreased with GGBFS substitution with a decrease of 57%, 58%, and 60% for 10%, 20%, and 30% GGBFS substitution, with a significant decrease 10 to 30% GGBFS substitution is able to make the mortar impermeable. This is the coefficient of permeability with GGBFS. The permeability coefficient is directly proportional to the depth of water penetration. First crack load with GGBFS and ultimate load with GGBFS. Flexural test on specimen SC20 VF 1.2, SC20 VF 1.8 and SC20VF 2.4 produce the highest first crack with an increase of 3%, 27%, and minus 9% compared to the control specimens. Fractional stress on SC30VF 1.2, this is SC30VF 1.8 and SC30VF 2.4 produce the highest ultimate loads with increases of minus 16%, 14%, and 4% compared to the control specimen. Now, like this, the highest in GGBFS 20% with VF 1.8%, 20% with VF 1.8%, the first crack load. The increase, this is the result. Next, the ultimate load, the highest is this 30% GGBFS with VF 2.4% with increase, this is minus 16%, 40%, and 4% compared to the control specimen. And then discussion. This is water depth penetration test, and this is the result of fractional test on ferrocement. In this discussion, in addition, 10% to 30% GGBFS substitution can also increase the compressive strength of concrete mortar. These results are in accordance with some previous results that GGBFS can increase compressive strength. This in paper. Similar to permeability, 10% to 30% GGBFS substitution can reduce the depth of water penetration so that the mortar is impermeable. The results in this study are in accordance with previous studies. This is in paper. The color produced due to GGBFS substitution is also lighter and shinier, enhancing the appearance of the concrete. The strength of ferrocement with GGBFS substitution in this study obtained results that did not significantly increase compared to without GGBFS substitution. This is in line with the statement stating that the increase in strength of concrete with GGBFS is at a higher maturity period, i.e. 56 days or more on the paper. Conclusion. Based on the result, it was found that the use of GGBFS in mortar can provide good mortar performance. Compressive strength increase and permeability decrease due to GGBFS substitution. The results of research on mortar obtained a statement that the substitution of GGBFS 10%, 20%, 30% has the same trend or not different, so that it can be used as a reference for the percentage of GGBFS used in a job. Test result on ferrocement reinforced with wire weld mesh did not significantly improve fractural strength and cracking behavior. It happens one of them due to the age factor of concrete, where at the age of 28 days, the GGBFS its material has not reached its maximum strength, thus causing the fractural strength and cracking behavior not to increase significantly. Recommendation. However, the use of GGBFS is recommended as a cement replacement material with a percentage of 10% to 30%, which can increase the strength of mortar, increase the impermeability of mortar, and can save costs because it is cheaper than the price of cement and save cement usage. Thank you to PT Krakatau Cement Indonesia for supporting the researcher by providing GGBFS in this research. And thank you for your attention, ladies and gentlemen. Good morning. Wassalamualaikum warahmatullahi wabarakatuh.